Alright, so I'm going to start Chapter 3 with Section 3.1. For the first few problems, you're going to see graph paper, and all the problems that I'm using this graph paper for, these are not in the handout. This is just a review. If you are real comfortable with lines, slope, intercepts, vertical and horizontal lines, you can fast forward until you see this page, and that's the first page of stuff that's test-worthy. I suspect that a lot of you have forgotten a lot about lines, and the review can't hurt. So it's probably going to be a 10 to 15 minute review, and like I said, if you're real comfortable with lines, you can fast forward straight through it. Theoretically, everything that I'm saying here you already know, because you do it in beginning algebra or the last high school class. But if you don't remember lines, this can't hurt. So one of the big words in lines is a slope-intercept form of a line, or the y equals mx plus b. Y equals mx plus b is considered the slope-intercept form of a line. And if you have an equation that has a y and an x, and there aren't any exponents, and there aren't any x's in denominators of fractions, then the graph is going to form a straight line. The b is going to be the y-intercept, and the m is going to be a slope. Here, this is an example of a line, of an equation of a line written in slope-intercept form. I'm just randomly making this up, about y equals to 2/3 x minus 4. When I see an equation of a line that's written in slope-intercept form, meaning it's solved for y, and I have a number times x and then a constant, I know lots about the graph. Very specifically, for this, I know that the slope of this graph is going to be 2/3. Number in front of the x without the x. And I know the y-intercept is going to contain the point -4. Y-intercepts, because they're points on the graph, they need both an x and a y. Y-intercepts always have a 0 for the x, and then the y is whatever the y-intercept is. So I should know those two things by just glancing at the equation. I also should be able to graph this. To graph an equation of a line that's written in slope-intercept form, first you plot the y-intercept. So to graph, that's why I have graph paper here. I could actually spell graph. You plot the y-intercept. In this case, that's the point 0, -4. It's -4 on the y-axis. And then I use the slope. The numerator is the up or down direction. If the numerator is positive, you go from that point, you go up. The denominator, since it's generally positive, is usually the right direction. So now I'm going to use the slope to get another point. And this slope is a positive 2/3, so I'm going to go up 2 and right 3. So from the point 0, -4, I go up 2, right 1, 2, 3, get a point. That's technically enough to graph, but I could do that again to make a more precise graph. So I'm going to do that again. I'm going to go up 2, right 3. I could do it again. I can go up 2, right 3. Could even do it again, but I'm kind of out of room. you'll see that every one of those points lies on a straight line. So I could label the points if I needed to. Here's the point 3, -2. This is the point 6, 0. This is the point 9, 2. So I can get lots and lots of points, and I can draw a line that goes through those points. And it's not a coincidence that all those points lie on a straight line. Usually I put little arrows at the edges of my lines if I think about it, because the graph goes on forever and ever, and it doesn't stop. Even though I stopped drawing the line, it doesn't mean the line actually stops. So I'll kind of continue with this slope-intercept form and beat it a little bit more. If I gave you this equation, y equals -1/4 x plus 8, because it's written in slope-intercept form, I know that the slope of this line, we usually use the letter m, is m equal to -1/4. I know that the y-intercept, it's not technically wrong just to say 8, but it's better because the y-intercept is actually a point on the graph to write it as a point. And when we write points, we write x's first and y second, and y-intercepts always have x equals 0. So I should be able to identify the slope, should be able to identify the y-intercept, and I should be able to make a pretty nice graph. To make a graph of this, I'd plot 8 on the y-axis because that's the y-intercept, that's the point 0.8. And then the slope tells me the numerator is negative, so I'd go down 1, and the denominator is positive, which usually generally always is, so I'll go right 4. So I'll go down 1, right 1, 2, 3, 4. There's a point on the graph, and then down 1, right 1, 2, 3, 4. There's another point on the graph. It'd be hard for me to get another one if I went down 1, right 1, 2. I'd have to kind of estimate it, but I can keep going, but once I run out of grid, my going gets kind of messy. And so this would be the best I can do in terms of drawing a line. And again, I usually stop my line short, but I usually put arrows at the end of it if I think about it, because the line doesn't change, it doesn't end. And I can plot these points if I want. That's the point 4, 7. This is the point 8, 6. This point would be a little bit harder to get. I could get it if I want to, especially if I look at the pattern. The x's are going up by 8. The y's are going down by 1. So I should have drawn here, which would be the point 12.5, even though it kind of doesn't fit on my grid. Let me do another one of these before I get into something else you need to remember about lines. So I'll write another equation, and I'm not going to have it in slope-intercept form. How about this? If I gave you this, 6x plus y equals to -5. If I asked you to identify the slope and the y-intercept and sketch a graph, it would be completely wrong to say that the slope is 6, or wrong enough that you'd lose points if it was a test question. I can only tell you what the slope and the y-intercept of a line is without having to do algebra if the equation is solved for y. So for this problem, because the equation is not solved for y, I don't know what the slope is. So if I just did a little bit of rewriting by minusing 6x from both sides, I can rewrite the problem so that I can tell you what the slope and the y-intercept is. So if an equation is a line, meaning you don't have exponents on the x's and the y's, you don't have an x in the denominator of a fraction, in order to be able to pick out the slope and the y-intercept, the equation needs to be solved for y. Now that I've took the time to rewrite the line, the slope is going to be -6, and the y-intercept is going to be the point 0, negative 5. This is going to be tough for me to graph. I'm going to unfortunately run out of room on my graph real quickly. If I wanted to graph this, the y-intercept's not hard for me to plot. It's the point 0, negative 5. The slope, I only see one number, so I'm not exactly sure what to do in terms of up or down and left or right. So I'm going to rewrite the slope as a fraction. I'm going to write it as negative 6 over 1, because any integer can be written as a fraction by writing it over 1. The negative 6 tells me to go down 6. The positive 1 tells me to go right 1. So to get a graph, I kind of messed up here because I'm going to go off my grid or off my coordinate system. I'm supposed to go from the y-intercept and go down 1, 2, 3, 4, 5, 6, right 1. I'm only going to do that once. If I want to get another point, I can do the backwards of this, meaning instead of going down 6, right 1, because that already took me off my graph, I could go up 6, left 1. Let's watch what happens when I do that. From this point, if I go up 6, 1, 2, 3, 4, 5, 6, left 1, I get a point on the line, and it didn't run off the grid. So you can do exactly the opposite. Instead of going down and right, you can go up and left. If I did that again, up 1, 2, 3, 4, 5, 6, left 1, I'm still on the same line. So now I have a bunch of points that all line up on the same line. So I'm going to connect them the best I can. Draw my arrow. So if your slope is kind of your slope and your intercept is defeating you because you're running off your graph, you can go backwards, do the exact opposite. Instead of down and right, if I go up and left the same units, I'm still going to be on the same line. So that's the beginnings of slope-intercept form. These are nice equations because they had both x's and y's, and either they were written in slope-intercept form or it was really easy to get them in slope-intercept form. Not all equations of lines have both x's and y's. Sometimes we have equations that graph to be lines that only have one of the letters. Like the equation, let's say y equal to 4. If I asked you to graph, find the y-intercept, and the slope. This would probably push a lot of you to the point where you just couldn't do it. For the most part, I kind of do these from memory, but it's real easy to figure out why the line looks the way it looks. So when you're missing a letter, you either get a line that's horizontal, parallel to the x-axis, or vertical, parallel to the y-axis. Equations with only y's are always going to graph to be horizontal lines. Means they're going to be parallel to the x-axis. What I'm going to do to graph any line that has only a y is I'm going to plot some points. And every point I'm going to plot is going to be on the y, it's going to be where 4 is on the y-axis. So all of these points that I'm drawing are all going to be on this line because they all have what they need to have. If I look at the points that I've just plotted, I plotted the point 0, 4, I plotted the point 3, 4, I plotted the point 6, 4, I plotted the point negative 3, 4, and I plotted the point negative 6, 4. I plotted maybe way more points than I needed to plot, but I just wanted to emphasize all of these points have to be on the line y equal to 4 because the only criteria to be on the graph of the line y equal to 4 is that the y coordinate of the point is 4. So I say this is a horizontal line because every point that's on the line, every point that has y equal to 4, lies on that horizontal line. So that's a graph of that line. Once I have a graph of a line, it's not hard for me to identify what the y-intercept is, because I just look at the y-axis. And for this graph, the y-intercept is the point 0, 4. Slope's another deal. If I'm clever, I might know the slope of this line by just looking at it. And if I'm not clever, if I don't remember lines, there's another way to get slope. So I can't look at the equation because there's not an x. I can't just pluck off the number in front of the x and say, well, the slope of this. If you might just know, well, the slope of this line is this number, and could be correct. If you don't know the slope of the line, there's a way to get the slope if you can pick any 2 points on the line. So if you don't know the slope, you can compute the slope by using the slope formula. The slope formula is slope equals y2 minus y1 over x2 minus x1. So in order to find the slope of a line that you have points on the line but not an equation that helps you find the slope, you need to pick 2 points. A first point and a second point. It doesn't matter, whichever points you pick are going to be fine. It's not wrong to call one point a first and one point a second point. So I'm going to call that point my first point. So that means in my formula, the x1 is going to be a 3. It's the x coordinate of the first point. The y1 is going to be a 4. So when I go to find the slope of this using the equation, slope is y2 minus y1 over x2 minus x1. After the minus sign in the numerator, the y coordinate of the first point I pick is going to be put. And in the denominator, after the minus sign, the x coordinate of the first point that I pick is going to go. So I've picked a first point. Now I need to pick a second point. There isn't a right and a wrong point to pick. I'm going to pick the point 6, 4. I don't like picking points that have negatives in them because they mess me up. And I'm going to put those numbers into the formula. Very specifically, the x2 in the formula stands for the x coordinate of the second point that I picked. So in the denominator, where the x2 is to the left of the minus sign, I'm going to put the number 6. In the numerator, I need to put the y2, and the y2 stands for the y coordinate of the second point that I picked, which is 4. I can do this with or without my calculator. With my calculator is probably safer, so I can go 4 minus 4 over 6 minus 3. And when I do that, I get 0. Because this is really 0 over 3. And any fraction with a 0 in the numerator is equal to 0. So the slope of this line is 0. If you would have picked different points for your first point and your second point, it wouldn't matter. You're going to get exactly the same slope. Let me do another equation with only a y. How about something like this? Y equals negative 3. I'll say sketch a graph. Find the y-intercept. And find the slope. Because the equation is missing an x, it's easy for me to graph. I'm just going to go to the y-axis and find negative 3. And make a bunch of points on negative 3. It doesn't matter which points I make, but I'm just going to randomly draw a bunch of points. 2 is all you really need, but I'm doing way more than 2. These are all points on the line y equal negative 3. If I look at the points that I've just drawn, I've drawn the point negative 6, negative 3, negative 3, negative 3, 0, negative 3, 2, negative 3, 5, negative 3, and 8, negative 3. I did way more points than I need, but all of these have to be on the line y equal negative 3 because every single one of them, if you could actually read my y's, they all have a y of negative 3. So my graph of y equal negative 3 is going to be a horizontal line. When you only have a y, your graph is always horizontal, parallel to the x-axis. So this is, an adequate graph. The nice thing about when you have a graph, it's easy to get the y-intercept. The y-intercept is where the graph crosses the y-axis. So the y-intercept of this graph is 0, negative 3. If you want to do algebra to compute the slope, you need to pick 2 points. You need to pick a first point and a second point. And that's what I'm going to do here. So I'm going to use the slope formula. Slope is y2 minus y1 over x2 minus x1. And I'm going to get the slope by using that formula. I'm going to pick a first point and a second point. And it doesn't matter which points I pick. Any point will help me give you the same slope. I'm going to call my first point 0, negative 3, which is that point there, which means in the formula, x1 is going to be 0 and y1 is going to be negative 3. So for this line, when I go to do its slope, in the denominator, next where the x after the minus sign, I'm going to put a minus 0 because that's what the x1 is. In the numerator, I'm going to put a minus negative 3 because that's what the y1 is. When I have two negatives, I usually put a parentheses. I need to pick a second point, and it doesn't matter which point I pick, but I certainly don't like taking negatives. So I'm going to pick, how about that point for my second point? I'm picking the point 2, negative 3, and into my formula for x2, to the left of the minus sign in the denominator, I'm going to put the number 2 because that's the x coordinate of the second point that I picked. In the numerator, to the left of the minus sign, I'm going to put this y, that negative 3, because that's the y coordinate of the second point that I picked. Now I'm going to do this on my calculator to be safe. I'm going to go negative 3 minus negative 3 over 2 minus 0, and when I hit enter, my calculator tells me it's 0. And that's not, it shouldn't be surprising, because if I did the algebra, the double negative goes positive. What I get is 0 over 2, and that's 0. The slope of this line is 0. The slope of the last line was also 0. It turns out that if you only have a y, that the slope is always 0. So all horizontal lines, which are lines that only have y's, have slope of 0. We do one more with only a y, then I'll do some with only x's. So it's slightly more complicated. If I gave you something like this, y minus 5 equal to 0, and I asked you to graph, identify the y-intercept, if I could actually spell that, and find the slope. So this is a little bit different. The first two problems that I gave that only had a y had the y solved for, and I need that. If the y isn't solved for and I try to graph, I might mess up. So before I do the graphing part of this, I'm going to solve the equation for y. When I solve the equation for y, I'll add 5 to both sides and get y equal to 5. That's what I need to graph. I need to graph points that have 5 for the y. So I'm going to graph a few points. Seems like more than enough points here. Here's the point 0, 5. It belongs on the line because its y coordinate is 5. Here's the point 2, 5. It also belongs on the line because its y coordinate is 5. Here's the point 6, 5. It belongs on the y line because its y coordinate is 5. This is kind of overkill, but it's good enough. When you only have a y, your graph is going to be a horizontal line parallel to the x-axis. So there's a line that's perfectly adequate. I have more points drawn than I need, but it's good. The y-intercept is the point 0,5, and the slope should be 0. I'm going to go ahead and verify that, but you could safely say that that line has a slope of 0 without doing the algebra, but I'm going to do some algebra to show my slope. So I'm going to get my first point, 0,5, and I'm going to use the formula m equals y2 minus y1 over x2 minus x1. So for me, my m after the minus sign in the denominator, there's going to be 0 because that's the x-coordinate of my first point. So the 0 is an x1. The 5 is going to be a y1, and it's going to go in the numerator after the minus sign. Now I need a second point. I'm going to call my second point the point 2,5, and its numbers go into the formula. My x2 is the x-coordinate of the second point. It belongs in the denominator. My y2, the y-coordinate of the second point, belongs in the numerator to the left of the minus sign. I can do this without a calculator, but I like using my calculator, so I'm going to go 5 minus 5 over 2 minus 0, and I'll get 0, is what I thought was going to happen anyways, because this gives me 0 over 2, which is 0. So that's equations of that graph to be lines that only have y's. The kind of the parallel to this, or the perpendicular to this technically, are equations with only an x. So if I made up an equation that only had an x and asked us to do the same thing, so here's the equation x equal to 3. If I said sketch a graph, find the y-intercept, because that's what we've been doing all day here, and the slope. So to sketch a graph, every point on the line, its x-coordinate has to be 3. So I'm going to make all the points that I can think of that fit this. Here's the point 0, 3. It belongs, here's the point 3, 0. It belongs on the graph because its x-coordinate is 3, and that's what it takes to be on the line x equal to 3. I'll draw another point on the graph. I didn't leave myself, if I can actually do it right. Here's another point on the graph, and that's really, John, yeah, that's good. Here's the point 3, 5. It belongs on the graph because its x-coordinate is 3. Here's another point on the graph. Here's the point 3, negative 4. All three of these points, now that I've drawn them more or less correctly, they belong on the line because all it takes to be on this line is your x-coordinate, and this is your x, has to be 3. I've drawn 3 points. I can draw 300 points, or I could draw 2 points. It's not going to matter. They're all going to line up on the same vertical line. When you only have an x in your equation, the graph turns out to be a vertical line as opposed to a horizontal line. So only x, I'm going to get a vertical line. So I have the graph part done. Now I want to find the y-intercept. Well, this is the y-axis. The y-intercept, by definition, is a point where the graph crosses the y-axis. There's a y-intercept of 0, 5. There's a y-intercept of 0, negative 3. There's a y-intercept of 0, negative 5. There's a y-intercept of 0, 8. Every graph that I've drawn so far, if I looked at the y-axis, I could find where the graph crossed the y-axis. It was easy to identify the y-intercept. This graph, if I look at the y-axis, it doesn't cross the y-axis. That means that this graph doesn't have any y-intercept. It flat out never crosses the y-axis, so it doesn't have a y-intercept. Slope is also yicky on this one. I'm going to do the slope using the slope formula. I'm going to call that my first point. So I'm going to find the slope using y2 minus y1 over x2 minus x1. My first point that I picked is the point 3, 0. So in the slope formula, in the denominator where the x1 belongs, I'm going to put a 3 after the minus sign. The minus sign's from the formula. The x1 is the x-coordinate of the first point I picked. In the numerator, for the y1, I'm going to put the number 0 because y1 stands for the y-coordinate of the first point that I pick. I'm going to use this for my second point. It doesn't matter if you use different points than me, you're going to get the same answer. So my second point that I picked is the point 3, 5. So in the formula, the x2 goes to the left of the minus sign. The x2 stands for the x-coordinate of the second point that I picked. The y2 goes in the numerator. It stands for the y-coordinate of the second point that I picked. So I'm getting 5 minus 0 over 3 minus 3 for the points that I picked. And when I do this, 5 minus 0 over 3 minus 3, I'm going to get a math error because I'm getting 0 in the denominator. This is actually undefined because this gives me 5 over 0. And any fraction that has a 0 in the denominator we say is undefined. So the slope of this line is going to be undefined. That's everything I wanted to do with that equation. I'm going to do one more. I'll keep it a nice positive one with the x's, and then I'll get into the handout. So let me do the same thing. Let's do x minus 4 equals 0. Very specifically, how about even better this? 2x minus 4 equal to 0. I'm going to graph, find the y-intercept, and find the slope. I know because the equation only has an x, the graph is going to be a vertical line parallel to the y-axis. I can't get into graphing mode until I have the equation solved for x. So I'm going to add 4 to both sides and get 2x equal to 4, and then divide both sides by 2 and get x equal to 2. That's the equation I'm going to graph. The graph of 2x minus 4 equal to 0 and x equal to 2 are the same. It's easier for me to graph this. So I'm going to find some points. To be on this graph, you have to have 2 for your x. So I've drawn I drew 3 points. Here's the point 2, 6, 2, 3, and 2, 0. It's enough to be on this line. All you need is your x-coordinate to be 2. All 3 of those points have an x-coordinate of 2. Turns out that every line that only has an x in the equation draws to be a vertical line parallel to the y-axis. So there's a graph. This graph doesn't cross the y-axis, so it doesn't have a y-intercept. If I go to do the slope, it's going to be undefined, but I'll do it using the points. I'm going to pick 2 points. It doesn't matter which I do first and second. I'm going to go first point, 2, 3, second point, 2, 0. For my slope, I form a fraction. In the numerator, it's the y-coordinate of the second point, which is 0, minus the y-coordinate of the first point, which is 3. In the denominator, x-coordinate of the second point, which is 2, minus x-coordinate of the first point, which is 2. If I simplify this, this gives me negative 3 over 0, which is going to be undefined because any fraction with a 0 in the denominator is undefined. And so the slope is undefined for this problem. So in general, if I wanted to kind of review lines that only have x's and only have y's, if an equation only has an x, the graph is a vertical line as opposed to a horizontal. Vertical lines go up and down. The graph has no y-intercept. It goes parallel to the y-axis, so it doesn't cross the y-axis. And the slope is undefined. If I have only a y, the graph is a horizontal line, it has a y-intercept, and the slope is 0. That's minimally important, but it comes up a little bit in this section, and you just kind of have to know it. The other things that I snuck in here is the y equals mx plus b formula. Then if the equation has an a y and an x, solve for y. The number in front of the x is the slope. The constant is the y-intercept. And we also have the slope formula, m equals y2 minus y1 over x2 minus x1. That's everything that we kind of need to remember about lines that isn't directly in the homework or enough in the homework that I could do it just by doing problems. So now I'm going to start doing the actual problems from the section, and the first few problems are going to be a little different than what I did, but I don't feel so bad about that because they're not hard. So 1 through 16 ask me to find intercepts, but not just the y-intercept. They ask me to find both the x and the y-intercept. If the equation, these are all going to be lines because they just have x's and y's, no exponents, no x's and denominators of fractions. Everything here is going to graph to be a straight line. And if the equation was solved for y, the and graph part would be easy. I'd know the y-intercept, I'd use the slope, and I'd kick out a graph very easily. Most of the equations between 1 and 16 aren't written in a very desirable way to find the y-intercept or sketch a graph. That being said, it's not impossible and it's not that hard to answer all parts of this question. So I'm going to do algebra for each one of these. First, I'm going to find an x-intercept. In general, x-intercepts are harder to find than y-intercepts because usually lines are solved for y and the y-intercepts are easy to get. To algebraically to do this, I'm going to replace the y with 0 and solve for x. Sometimes you'll see teachers do this. To do the x-intercept, I'm finding a point on the graph and I'm plugging y for 0. So I'm going to do that. I'm going to plug y for 0. I'm going to go 3x plus 4 times 0 equals 24. Do the algebra here. This piece zeroes out. This gives me 3x plus 0 equals to 24 because 4 times 0 is 0. Now I'm just going to divide by 3. And I'm going to get x equal to 8. So the x-intercept for this graph, where this graph is going to cross the x-axis, is going to be at the point 8, 0. So that's one of the things I was asked to find. The next thing I'm going to do is find the y-intercept. And to find the y-intercept, when the equation isn't solved for y, I replace the x with 0 and solve for y. Table-wise, it would look like that. Algebraically, I'm going to go 3 times 0 plus 4y equals to 24. 3 times 0 is 0, so this simplifies to 4y equals to 24. And when I divide both sides by 4, I get y equal to 6, which I could put in that table. And in terms of my answer, the y-intercept is the 0.06. So I've done find the x-intercept, find the y-intercept, and now I'm going to sketch a graph, and it's enough the least amount of points you can have to sketch a line is 2. I have 2 points. I'm not going to go try to find a third point because it's not easy to do. I'm going to plot the intercepts. So here's the point 8, 0. Here's the point 0, 6. So it's finishing up problem 2. And I'm just going to connect them. I'm not even using a ruler. That would be a perfect and graph part. It's, if I made a math error on one of the intercepts, doing more than 2 points would make my math error pop out at me. But this, I feel comfortable with my work, and I'm going to stop there and only graph with 2 points. For all the problems between 1 and 16 that have both x's and y's, I think this is what I'm going to do. Problems get harder because fractions start coming up and negatives start coming up. And some of the problems, the x and the y-intercepts are the same, and that's a whole nother level of difficulty. So I'm going to do exactly what I'm asked to do. I'm going to find the x-intercept. It's going to be a point. To find an x-intercept, you plug 0 in for y, and you solve for x. So I'm going to go 2x minus 0 equals to 8. The minus 0 part goes away. This left side simplifies to 2x equals to 8. I divide both sides by 2 and get x equal to 4. So what I found graphically is the point 4, 0. So the x-intercept, it's not really right to say x equal to 4. It's not horrible to say that. But I'm going to say it's the point 4, 0. Now I'm going to find the y-intercept. To find a y-intercept, you let x equal to 0. So I'm going to go 2 times 0 minus y equals to 8. When I do that, the 2 times 0 goes away. It's equal to 0. I get minus y equals to 8. I'm going to divide both sides by a negative 1. On the left side, the 2 negatives will divide to be positive. On the right side, 8 divided by negative 1 is negative 8. So I've kind of filled in my table. I don't have to draw this table part at all. In fact, I generally don't. I'm going to say the y-intercept is the point 0, negative 8. Now I'm going to sketch a graph. So I'm 2/3 of the way done. I found the x-intercept, the y-intercept. Now I'm going to sketch a graph. So to sketch a graph for problem 4, I'm going to plot the x-intercept, which is the point 4, 0. The y-intercept, which is the point 0, negative 8. And even though that's only 2 points, 2 points will get you a line. So I'm going to connect those 2 points with a line. And you don't need graph paper for this. You can draw your own grid and go 1, 2, 3, 4. Here's the point 4, 0. 1, 2, 3, 4, 5, 6, 7, 8. Here's the point 0, negative 8. And there's a graph. So you can be very crude with your graphs. You don't need to be this precise at all. You don't need to bust out graph paper to do graphs of lines. You can draw your own grid, guesstimate where the x and the y-intercepts were, plot them, connect them. It just doesn't need to be that accurate. 6 is a really tough problem because the x and the y-intercept they're the same point. So algebraically, at first I'm going to find the x-intercept. I find the x-intercept by plugging in 0 for y. So I'm going to go x plus 2 times 0 equals to 0. This simplifies to just x equal to 0. So the x-intercept is the point 0, 0. That's really disappointing when that happens. For the y-intercept, I plug 0 in for x. I go 0 plus 2y equals to 0. The 0 goes away. This leaves me with 2y equal to 0. And then I divide both sides by 2. If you forget on the fractions, any fraction with 0 in the numerator is equal to 0. To do 0 over 2, you get 0, because any fraction with 0 in the numerator is equal to 0. So this gives me y equal to 0. This gives me a y-intercept of 0, 0. The real unfortunate thing is when I go to graph the intercepts, it's at the origin. And that's only 1 point. 1 point doesn't tell me what the line looks like. It doesn't tell me where I should go. So in order to finish up my graph, I'm going to use some strategy that I already know. I'm going to solve an equation for y. If I solve this for y, I know the slope. And if I know the slope, I know how to get around on this line. I'm going to emphasize this is really 1x plus 2y equals to 0. I'm going to do a couple steps of algebra to solve this for y. Specifically, I'm going to minus 1x from both sides and get 2y equals negative 1x. I could put the plus 0 here if I want to, but I don't need it. And then I'm going to divide by 2. And I'm going to get y equals negative 1/2 x, technically plus 0. Now I know how to graph this. 0 is the y-intercept. Have it already. Negative 1/2 is the slope. If I can take the equation of a line and solve it for y, the number in front of the x is the slope. And I don't know what the slope is until the y is solved for. Now I know the slope. I'm going to go down 1 and right 2. So from my y-intercept, I go down 1, right 2, get to it, and I can do it again. Down 1, right 2, down 1, right 2. I can do that as many times as I want to get another point. So when it's an unfortunate problem that the x and the y-intercept are the point 0, 0. You only get 1 point. A strategy to finish up your graph is to take the equation, do the algebra to solve it for y. Once you get the equation solved for y, you know the slope, and the slope will help you finish out the graph. You start at your y-intercept and do what the slope tells me. Here the slope tells me to go down 1 and right 2, and I just did that a bunch of times, and that took me where I needed to be. All right. I don't know if it gets worse or not. Oh, another one that has 0, 0. So this is the same style of problem. When you have the 0 over here, you're going to get 0, 0 for both the x and the y-intercept and have to do work to find your slope. So for the x-intercept, I let y equal to 0. I go 4x plus 3 times 0 equal to 0. The 3 times 0 piece is 0. It goes away. It leaves me with 4x equal to 0. I divide by 4. I divide by 4. I get x equal to 0. So for one of the answers to this problem, the x-intercept is the point 0, 0. If the x-intercept is 0, 0 and it's a line, the y-intercept is also going to be 0, 0. To do the y-intercept, I plug in 0 for x. I go 4 times 0 plus 3y equals to 0. The 4 times 0 piece is 0, so you get 0 plus 3y is 0, which gives me 3y equals to 0. And then I divide by 3, divide by 3. Any fraction with 0 in the numerator is equal to 0. So I get the y-intercept is also the point 0, 0, which means I'm going to need to know the slope. So I'm going to find the slope before I even get into my graphing mode, because I'm going to run into the same problem that I did last time. So I have 4x plus 3y equals to 0. I'm going to solve this for y by minusing 4x and dividing by 3. By minus 4x, the left side just has 3y. The right side, I don't need the 0. I could have the 0 if I want to see the b, but I don't need it. Now I'm going to divide by 3 and get y equals negative 4/3 x. So my slope is negative 4/3. And the only reason I'm taking the time to find the slope is because the x and the y-intercept are only 1 point. If they were 2 points, I'd just connect the points and be done. But they're not, so I needed to use the slope too. I'm out of graph paper already, but I can certainly sketch a graph on non-graph paper. So to sketch my graph, I'm going to plot the x and the y-intercept, which is the point 0, 0. and I'm going to go down 4 and right 3. So down 1, 2, 3, 4, right 1, 2, 3, point, down 1, 2, 3, 4, right 1, 2, 3, point. Can do that all day. Did it twice just to get a nice accurate line. Notice I didn't really take the time to label many points. That's completely okay. This would be -4 on the x-axis, y-axis 3 on the y-axis. This is technically the point 3, -4. On the test, if I asked you to graph, you'll be given graph paper, so you can just look at it and know what the point is. Similarly, I think that's the point 6, -8, because I'm going to go over 3 more to 6, down 4 more to -8. But you don't have to label the points. It'd be nice. You should probably label the x and the y-intercepts, but any additional points, I'll be able to tell what they are because there'll be graph papers right there for you. All right. Hey, getting to the problems now that only have x's or only have y's. So, I'm going to do the graph part first because that's the easy part for me. For this line, because it only has an x, I'm going to sketch my graph first. I was asked to graph. In the other problems, I had to do work before I knew what the graph was. But when an equation only has an x, I know the graph is a vertical line. So the graph is going to go through -3 on the x-axis. I'm out of graph paper, so I'm just sketching it freehand here. Notice I didn't even label a point. I knew once I found -3 on the x-axis and drew a vertical line that I'd have my graph. I can certainly label as many points as I want to. What's going to happen when I label my points is they all are going to have -3 for the x coordinate. So there's the graph part. I'm comfortable with that. Turns out I can answer the other questions equivalently easy. There's going to be no algebra for me to do. If I understand pictorially where the x and the y-intercepts are, or on the graph where the x and the y-intercepts are, I can answer the question for where the x-intercept is and the y-intercept is without doing any graph, without doing any algebra, because the x-intercept is where the graph crosses the x-axis. So for this line, the x-intercept is the point -3, 0. The y-intercept is where the graph crosses the y-axis, and this graph never crosses the y-axis, so there's no x-intercept. A little while back when I was summarizing lines that only have x's and lines that only have y's, on that little summary, I said exactly that. I said lines that only have x's have vertical lines, so I knew to draw a vertical line. It has no y-intercept. I was able to say there's no y-intercept. I wasn't asked to find the slope. If I was asked to find the slope, I'd say it's undefined, but I didn't have to say that. So that's everything there was for number 10. No algebra involved, which made it a nice problem. 12 is similar in that it only has an x. And when I only have an x, I know I'm going to get a vertical line. But to know how to draw that vertical line, I need to solve the equation for x if it's not already solved for x. So when I go to do a graph for this problem, I'm out of graph paper, so I'm going to do it right here. I'm going to find -4 on the x-axis and draw a vertical line, because when I only have an x, I get a vertical line. It'd probably be nice to show the intercept. That's the point -4, 0. I don't really need to show a single other point if I don't want to. So that's the graph of the x equal -4 or 3x equal to -12. These have the same graph because they simplify to the same equation. The x-intercept is where the graph crosses the x-axis, which is at the point -4, 0. The y-intercept, there is none because this graph never crosses the y-axis. So that's everything there is for that problem. 14 and 16 actually come out to be the same exact problem when you get into them. I only have a y. I'm going to do the graph part first because the graph part is easy for me. When an equation only has one letter, I'm going to get a line that's either horizontal or vertical, and when you only have a y, your graph is horizontal and it goes through that 4 on the y-axis. That's actually the point 0, 4. It's the only point I really need because it comes into my work. So I only had a y, I knew the graph was going to be horizontal, found 4 on the y-axis, drew my horizontal line. For the x-intercept part of this question, this is the x-axis. The graph never crosses the x-axis, so it has no x-intercept. And the y-intercept is where the graph crosses the y-axis, and that's the point 0, 4. So all of these problems that are missing a letter, I do the graph first, I answer the intercept second. If I only have an x, I get a vertical line. If I only have a y, I get a horizontal line. And the questions are reasonably easy for me to answer. 16 is a dumb problem on my part in that it doesn't turn into something new. If I'm asked to graph this, I'm going to solve it for y. I know that if I only have a y, I'm going to get a horizontal line. And to know where to draw that horizontal line, you have to have the equation solved for y. So I'm going to find 4 on the y-axis, draw my horizontal line. Might as well label that point the point 0, 4. When I go to answer the questions about the intercepts, they're the same. There's no algebra to do to find the intercepts when you only have one letter. This graph doesn't cross the x-axis, so there's no x-intercept. And it crosses the y-intercept at 4, y-axis at 4, so the y-intercept is 0, 4. Okay, that's the first style of problem. Second style of problem, for whatever reason, when I test over this section, this is the kind of problem that even the students that get 96 lose points on. So really, when you're doing the homework, focus on this bank of problems extra hard and make sure you can do all the problems between 17 and 28, because I put them on the test every semester, and every semester a lot of students mess them up. Maybe because they don't understand what the instructions are asking. The instructions say write in slope-intercept form, and then identify the slope and identify the y-intercept. What the instructions want me to do is first do algebra to solve the equation for y. Then you're done with your algebra. Then, without algebra, state what the y-intercept and slope are. So every equation between 17 and 28 isn't solved for y, and in order to get the first part of the instructions done, I need to do algebra. It's either 1 step, 2 steps, or 3 steps, depending on how complicated the problem is. Problem 18 is a 1-step problem. So I'm doing the first step of this problem. I'm writing it in slope-intercept form by minusing 3x from both sides. So part 1 of my answer, if I minus 3x from the left side, I'm left with the y. The 3x's cancel. If I do it from the right side, I get the 3x to the left of the 4. This is part 1 of my answer. This is considered writing in slope-intercept form. I'm not asked to graph, so I'm not going to take the time to graph. And now I need to identify that, hence there's no algebra here. I'm going to say the slope is m equal to -3. I'm not using the x with the slope, it's just a number in front of the x. And identify the y-intercept. The y-intercept is the b. It's going to be the point 0, 4. If you just said 4, y equal to 4, b equal to 4, it probably wouldn't take points off. But a y-intercept is a point on the graph, and every point has both an x and a y. Y-intercepts always have an x of 0. And that's everything there is for 18. So for each of the problems I'm going to do 20, 22, 24, 26, and 28. First, I'm going to do algebra to solve the equation for y. That's writing it in slope-intercept form. Once I'm done with the algebra, I'm going to look at my equation. The number in front of the x I'm going to say is the slope. The number after the x I'm going to say is the y-intercept, and I'm going to write it as 0, some number. So I'm going to do the same thing for 20. It's going to be way tougher because of the negative. So I'm going to solve this for y to get it in slope-intercept form. First step, algebra. Minus 3x from both sides. And that gives me minus y equals minus 3x plus 5. That's not solved enough for y because it's solved for negative y. I'm going to divide everything by negative 1 to get a positive y solved for, and that's what I need. So here, the two negatives will cancel to become a positive. I'm left with a y. With the x's, the two negatives cancel to become positive. And with the 5 divided by negative 1 is negative 5. You could use this, or you can use this for the slope-intercept form. So the writing it in slope-intercept form part of this, I can take either of those two answers, depending on whether you want to use the two signs with a parentheses or just a minus. Done with the hard part. Now I'm going to identify what the slope is. The slope is the number in front of the x. And I'm going to identify without any more algebra what the y-intercept is. And the y-intercept is the number after the sign written as a point with a 0 first. Problems are going to get progressively harder in terms of the solving it for y. For 22, I want to write it in slope-intercept form. I want to solve it for y. That's going to take me 2 steps. First step, I'm going to minus 3x. When I minus 3x, I get 12y equals minus 3x plus 36, and then I'm going to divide everything by 12. On the left side, the 12s cancel, I'm left with a y. On the right side, negative 3 over 12 reduces to negative 1/4, and 36 divided by 12 is 3. So this is part of my answer. It's the hard part of my answer. This is considered slope-intercept form. Now I can look at it and tell you that the slope is negative 1/4, and the y-intercept is the 0.03. It's everything there is to do for that. It wouldn't be uncommon to ask you to graph that, but since I didn't ask for a graph, I'm not taking the time to graph it. Next one's a little bit, 0 makes it a little bit tricky, but not horribly tricky. So I'm going to minus 3x from both sides to write this in slope-intercept form. Trying to solve it for y. For all these problems, I'm going to solve for y first, because that's what the instructions ask me to do first. So I get minus 5y equals minus 3x when I minus 3x from both sides. And now I'm going to divide both sides by minus 5. On the left side, the two negatives cancel, give me a positive y. On the right side, I get positive 3/5 x. That's technically, it's okay to call this slope-intercept form. Makes it hard to find the y-intercept when it's written like this. It would be better in terms of answering the second piece if you put a plus 0 at the end of this, because these two are equal to each other, because 3/5 x plus 0 is just 3/5 x. When you write it like that, you can tell what the y-intercept is. When you have it written like that, you might not notice the y-intercept. So this is perfectly fine for the beginning part of my instructions. Write this in slope-intercept form. Both versions make it easy to say the slope is 3/5. The top version makes it harder to know what the y-intercept is. The bottom version, I take this 0 that I inserted there and put it for the y part of the y-intercept. The x part of any y-intercept is always 0. (26) is infinitely harder. The y's on the wrong side. I'm going to get it onto the right side just to get this going. So the goal is to write this in slope-intercept form, which means to have it solve for y. And generally, we have the y on the left side, so it was odd that this problem had the y on the right side. Not that hard to get the y on the left side. I just added 5y to both sides, which makes the y on the left side, but also has the x on the left side. I need to get the x off the left side to the right side, so I'm going to minus 7x from both sides. And when I do that, I get 5y equals minus 7x plus 3. I almost have it solved for y, except for this 5. I need to divide everything by 5 to get it in slope-intercept form. So when I divide this by 5, I get y equals negative 7/5 x plus 3/5. This is considered slope-intercept form. That's the first part of what the instructions asked me to do for each of these problems. And it's the only part that needs any algebra. The next thing I'm asked to do is say what the slope is. The slope is going to be negative 7/5. And the y-intercept is going to be a fraction. It would be really unpleasant to graph this problem, but I'm not asked to graph it. I'm just asked to identify, after I have the slope-intercept form, the slope, which is a number in front of the x without the x, and the y-intercept. Y-intercepts, this is always the y-coordinate of the y-intercept. The x-coordinate of any y-intercept is always 0. Ooh, 28's the very worst problem. So I'm going to solve this for x. Lots of things I can do to solve this for x. They all are equivalently unpleasant, but let me do just kind of what I've been doing. I'm going to minus 2/5 x from both sides. The fractions make this really unpleasant. So I'm going to go 1/4 y equals to minus 2/5 x plus 3. Now I can either divide by 1/4, because that would be consistent with what I've been doing. So I could go divided by 1/4, divided by 1/4, divided by 1/4. That's completely okay to do. But dividing by 1/4 is the same as multiplying by 4. So it would be better if I multiplied by 4. I'm going to pretend that I wasn't so clever. I'm just dividing by 1/4, and I'm going to use my calculator. On the left side, 1/4 divided by 1/4 gives me a y. On the right side, time for this calculator. So I'm going to go negative, whoops, I'm going to go fraction, negative 2/5 over 1/4. And I get negative 8/5 for the number in front of the x. If I just multiplied this by 4 over 1, or 4, I would have did 4 times negative 2, got negative 8. If I multiplied by 4 over 1, I'd go 4 times this, 1 times that, negative 2 times 4 is 8, 5 times 1 is 5, and give me the negative 8/5 for the number in front of the x. Similarly, if I multiplied by 4 or 4 over 1, I'd get this being a 12 a lot quicker. But I can do this on my calculator easily enough. 3 divided by fraction 1 over 4, and I get plus 12. So because this calculator does fractions so amazingly well, I can make this horrible problem not so horrible by resorting to my calculator for the fractions. So here's the Slope-Intercept Form. For number 28, and then the slope is m equal -8/5, and the y-intercept, if I could actually read that, -8/5. Gosh, my 5 is equally sucky. And the y-intercept is the point 012. Alright, it's getting really long. I'll keep trudging along, but if you're failing on me, that's completely okay. You might need to pause this and come back to this video. Turns out there's not going to be too much new that we have in the rest of the section. The next problems, 29 through 34, just ask me to find a slope of a line, and they give me 2 points, so I'm going to use the m equals y2 minus y1 formula over x2 minus x1, because I'm asked to find a slope of a line, not an equation. I'm just asked for a number, and I'm given 2 points, and I did a bunch of these in the warm-up. So to find the slope of any line given 2 points, we can use the formula. Take the y-coordinate of the second point, -1, minus the y-coordinate of the first point, 1, divided by the x-coordinate of the second point, 4, minus the x-coordinate of the first point, 3. So that's how to find the slope of this line. And again, I'm going to resort to this calculator. I could totally do that by hand, but -1 over 4 minus 3 gives me -2. If I would have done this by hand, the numerator comes out to -2, the denominator comes out to 1. -2 over 1 is -2. That's all there is. It's a way easier problem than the last few problems. 32 gives me 2 points, wants me to find the slope. Slope given 2 points, you can use the formula y2 minus y1 over x2 minus x1. y2 is the y-coordinate of the second point that's written, which is -6. I'm going to put the minus sign from the formula. Then I'm going to put the y-coordinate of the first point which is written, which is -7. But double negative, you usually make the double negative stand out with the parentheses. The denominator, I need x2, which is the x-coordinate of the second point, which is -5. Minus sign from the formula. Then after that, in the denominator, the x-coordinate of the first point, which is written, which is 2. Use my calculator because it's easier. Fraction, -6 minus parentheses -7. You don't really need those parentheses, but it's nice. And then -5 minus 2 in the denominator, and I get -1 over 7 for the slope. If you did this by hand, the double negative in the numerator turns positive, and you get a +1. In the denominator, both the numbers are negative. You add them and keep them negative. You might get 1 over -7. When a fraction has just a single negative number in the denominator, you can move that negative out to the left of the fraction, or you can move it up to the numerator. So if you wrote 1 over -7, or if you wrote -1 over 7, or if you wrote -1/7, they're all equal to each other. That negative sign, you can shuffle it around. 34, before this calculator, I used to do by hand. It was horrible, horrible, horrible. With this calculator, it's not going to be so horrible. So find the slope. Take the y-coordinate of the second point, which is 1/6, minus the y-coordinate of the first point, which is 2/5, over the x-coordinate of the second point, which is 3/2, minus the x-coordinate of the first point is 1/3. It really is kind of senseless to do this by hand. It's not impossible, but it's really unpleasant. So in the numerator, I'm going to go 1/6 minus 2/5. In the denominator, I'm going to go 3/2 minus 1/3. And I get -1/5. Just because I can, I want to show you how to do it. I'll do it by hand, but I would never expect anybody to want to do this by hand. That's the answer. Fast forward if you don't want to see me do it by hand. By hand, I need to get the numerator simplified and the denominator simplified. In the numerator, I'd multiply to get 30s for my denominators. I would make this 5 over 30 minus 12 over 30. And in the denominator, I'd get 6's by multiplying by 3 over 3 and getting a 9 over 6 and a 2 over 6. So this comes out to be negative 7 over 30 divided by 7 over 6, because 5 minus 12 is negative 7, 9 minus 2 is 7. This is a mess. I can rewrite this as a division problem. This is negative 7 over 30 divided by 7 over 6. Now I can invert and multiply. This is negative 7 over 30 times 6 over 7, and I can cancel. 30 divided by 6 is 5. 6 divided by 6 is 1. Negative 7 divided by 7 is negative 1. 7 divided by 7 is 1. And I'm going to multiply negative 1 times 1, 5 times 1, and takes me to the negative 1/5. Almost done. Some of the problems at the end of this last grouping, 43 through 60, I'm not doing. I'm going to stop at problem 52. Problems 54 on ask me to find perpendicular and parallel lines, and those probably aren't appropriate for intermediate algebra, and I know I don't test on them. They're not going to be that big of a deal. So last group of problems ask me to use the point slope formula. I'm going to change those instructions. I'm going to say use the slope-intercept formula, and I won't introduce a point slope formula. We have enough formulas. I'm going to change these on the instructions. Use the point slope formula to write the equation of the line using the given information. So for each of the problems between 43 and where I'm going to stop at 52, I'm given information about a line and I want to find its equation. And every single problem I'm going to do, I know the answer is going to be in the form y equals mx plus b. My goal is to create an equation of a line in the form y equals mx plus b, and I need to replace the m and the b with numbers that fit the given information. Which means I have to know what the m and the b are, and some of that will require algebra. In the first problem, it's not hard to know what the b is, what the m is, because it's given. But I'm not given the b. Let's get some more graph paper so I can show you that my answers are correct. You don't need graph paper for these, but it's a good way to verify your answer is correct. So, for most of the first few problems, I'm given an m, I need to find a b. So my answer to this problem is going to be y equals 4x, because that's the m that works for this problem. Unfortunately, The 3, if you put 3 in for the b, you're wrong. So the whole algebra for the first few problems is to find the b. And how do I find a b? Given the information that I have, I'm going to use the y equals mx plus b formula. And in for the m, I'm going to plug the m that's given, which is 4. In for the x into that formula, I'm going to plug the x that's given, which is -1. In for the y in the y equals mx plus b formula, I'm going to give you the y that's given, which is 3. I'm going to change the formula so the letters y, m, and x are the numbers that are given. So the m, the x, and the y are all numbers that are given that I can plug into this formula. Now I'm going to do the algebra to solve this for b. Specifically, I'm going to multiply the 4 and the -1 and get +4. And I'm going to add 4 to both sides. When I do that, I get 7 equals to b. And that 7's a positive. It's going to go in my answer next to the 4x. The entire work that I needed to do for this problem is to do this step to solve these 3 or 4 steps to solve for b. If I want to check to see if my answer is right, the graph of this line should go through the point -1, 3. And so let me graph it. So this is optional, but the checking. I'm going to graph the line 4x plus 7. How do I do that? I plot 7 on the y-axis. I'd like to go, because the slope is 4 over 1, I'd like to go up 4, right 1, but I can't really do that because I'm out of room. So instead of doing that, I'm going to do the opposite. I'm going to go down 4, left 1. So from this, if I go down 4, left 1, down 4, left 1, I get the line that I need, that I graph. This is y equals 4x plus 7. The question is, does it fit the data? Well, what do I need for it to fit the data? It has to go through the point -1, 3. Beautifully, if this point right here is the point -1, 3. So the line that I came up with, y equals 4x plus 7, has a slope of 4, and it goes through the point -1, 3, so I know my answer is correct. Graphing is optional totally. The algebra isn't so optional. So for each of the problems here at the beginning, I'm going to do the same sort of algebra. So problem 46 is going to be unpleasant because of the fraction, but it's not going to be impossible. So first thing I want to do is know my answer. The answer that I'm going to write has to be in the form y equals mx plus b, but I replace the m with a number that fits the problem. I'm going to place the m with 2/5, and now I need to find the b. The whole algebra I'm going to do is to find the b in my answer. I'm going to use the equation y equals mx plus b to find my b. Specifically, I'm going to use that equation. I'm going to plug 2/5 in for m because that's the slope. I'm going to plug -1 in for x because that's the x coordinate. I'm going to plug 3 in for y because that's the y coordinate. Now I need to solve for b. So I get 3. On the right side, I can do this multiplication without a calculator because -1 times anything just changes its sign. And now I'm going to add 2/5 to both sides. Could do this without a calculator, but this calculator makes fractions so easy. So I'm going to go 3 plus fraction 2 over 5. I could actually do that. 3 plus fraction 2 over 5. My calculator gives me 17/5, which is completely fine for an answer. Not so fine for graphing. So in my answer, where the b in the formula goes, I need plus 17/5. That's the answer. This is going to be really a nuisance to check, but I'm going to try to check it for you just to show you that it works. By working, I need to plot the y-intercept and use the slope. 17/5 as a mixed fraction is 3 2/5. So I'm done. This is just the checking part, and it's completely optional. For checking, I'm going to graph y equals to 2/5 x plus 17/5. And this 17/5 is 3 2/5. So I'm going to plot 3 2/5, 1, 2, 3 2/5, kind of a little less than halfway. And then I'm going to go up to right 5, up to right 5, and graph my line. The only way my line is right is if it goes through the point that it has to go through. I have to fudge on it because I didn't use a ruler. And it's supposed to go through the point -1, 3. It's at least close enough without my ruler that I believe I'm correct. Because I was told the slope had to be 2/5. It is 2/5 because I went up to right 5, up to right 5. That's what you need for 2/5 for a slope. And it has to go through the point -1, 3. And it does. If your answer was this, if you did this for an answer, if you said my answer needs to be y equals 2/5 x plus 3, if you'd graph that, you'd go start at 3, then you'd go up to right 5. Your graph won't go through the point -1, 3. It goes through the point 0, 3. Ugh, I'm wearing out, which means you got to be wearing out, but I'll just trudge through this. Next one. Same sort of deal. My answer has to be in the form y equals mx plus b. The m is going to be 0, and I have to do the algebra to solve for b. The algebra to solve for b is I'm going to use the equation y equals mx plus b, and for the m I'm going to plug 0, and for the x I'm going to plug -1, and then for the y, I'm going to plug 2. I'm going to take the 3 numbers that are given, plug the 0 for the slope for the m, the x coordinate for the x, the y coordinate for the y, and do the algebra to solve for b. This is the easiest algebra yet because the 0 times -1 is 0. And I get b equal to 2. So I'm going to take that b and plug it in my answer. This is a completely correct answer. Probably a little bit more correct than it needs to be. Equivalently, I could just write y equal to 2 because the 0x piece is equal to 0. And I'm fading, so I'm going to skip the checking part because it's completely optional and I didn't make an error here. 50, same style of problem? No. 50 and 52 are not the same style of problem. They're two-step problems. Just going to do them, even though you might fade away. For these two problems, they're different. I'm not given the m nor the b. So first, for 50 and 52, I need to find the m. And then I need to find the b. To find the m, I'm going to use the slope formula. I'm going to use the x coordinate of the second point given minus the x coordinate, the y coordinate, y2, of the second point given minus the y coordinate of the first point given over the x coordinate of the second point given minus the x coordinate of the first point given. So in order to write an equation in the y equals mx plus b form, you have to have an m and a b. I wasn't given an m, I wasn't given a b. I had to do algebra to find each. The last 3 problems I was given an m, the only algebra I needed to do was to find b. This I don't need my calculator for. My m is going to be 7. So in my answer, I'm going to have y equal to 7x, and then I need something after the x. I need a b. There's 2 ways to get the b. I can use m equal to 7, x equal to 6, y equal to 3, using the first point along with the m, or I could use m equal to 7, x equal to 7, y equal to 10 using the second point. It doesn't matter. For both of these, if I use y equals mx plus b, I'm going to go y is 3 equals m, which is 7, times x, which is 6, plus b. Or I can go y, which is 10, equals m, which is 7, times x, which is 7, plus b. Both of these computations are going to give me the same b. The algebra for picking the first point gives me 3 equals 42 plus b, and then I minus 42 from both sides and get negative 39 equals b. The algebra with the second point, I go 10 equals 49 plus b, and then I minus 49 and get minus 39 equals to b. In my answer, that minus 39 goes after the x. And again, I'm going to skip the checking and just get done with this section. At the beginning of the next lecture, I'll probably do a couple review problems just to make you see these again. So for the last two problems that we're responsible for, you're given 2 points, you're not given an m, which makes the problem a little bit harder. We have 2 steps of algebra to do. Last problem I'll do for today, problem 52, because the rest of them, 54 through 60, about anything that says perpendicular or parallel, we're going to skip those. 58 and 60 are evil trick questions that won't come on the test. So 52, I want to find an equation for a line. I need both an m and a b. First, I'm going to find the m by making a fraction. I'll take the y-coordinate of the second point, which is 9, minus the y-coordinate of the first point, which is 8, divided by the x-coordinate of the second point, which is negative 5, minus the x-coordinate of the first point, which is negative 3. Safe to do this on my calculator because I'm tired. So 9 minus 8 over negative 5 minus negative 3. And my calculator tells me it's negative 1/2 is the slope. The negative could be in the numerator, it could be in the denominator, it could be to the left of the fraction. I like it in the numerator. Now I'm going to find the b. I can pick either point. They're both bad. I'm going to pick this point. So I'm going to go x equal to negative 3, y equal to 8, m equal to negative 1/2, and plug those in the formula y equals mx plus b. I certainly could have used this point, negative 5 for the x and 9 for the y. It doesn't matter. So here I'm going to go 8 equals m, which is negative 1/2, times negative 3 plus b. If you can't do this multiplication by hand, use your calculator. So I'm going to do that to be safe. I'm going to go fraction negative 1/2 times negative 3 gives me positive 3/2. The two negatives cancel out to be positive. So I get 8 equals 3/2 plus b. Now I need to minus 3/2 from both sides. And again, this calculator does fractions so well that I get lazy. Now I'm going to go 8 minus fraction 3/2. And I get 13/2 equals b. Ready to write my answer, because my answer, I just need to replace the m and the x and the b with numbers that are relevant to the numbers in the problem. So my answer, the equation of the line that does what it needs to do, is going to be y equals negative 1/2 x, there's the m, and now the b, plus 13/2. Alright, so hopefully you made it through here. You might have had to sit through this video on a couple different sittings, so it had to be long. The beginning of my next video, I'll review some of this end stuff just in case you're kind of fatigued when you got through it, when you went through it. Again, the stuff at the very, very end of this section, anything after 54, anything that talks about parallel or perpendicular, and any points that have duplicate x's, duplicate y's, you can skip. Alright.